All right, guys. Yeah, thank you everyone for joining us. I'm so glad you spare some time to join us, and especially thanks to our speakers to find a time out of their busy schedule to join us to do some talks about AI and Kubernetes, etc. So tonight, my time tonight, yeah, depends where you are. If you are from Europe, most likely you are in the morning. So the topic for tonight is the process is I'm going to introduce a little bit of our community. What I call is KSUG.AI or Cube Smart and AI User Group, and then followed by three awesome talks from our speakers. So on the screen you can see we are actually pretty strong community. If you have never heard of us, you might be interested to scan the QR code, or you can visit the link. By the way, the slides that we're going to share with you, you don't have to take the screenshot. I'm going to show you now where you can get the slides. Just give me 1 second. So I'm going to show you. So to get to the slides, has anyone has any experience why we are using Canva for the slides? I tell you why, Canva allow you to create the slides. It can make the in read-only mode. So if I create the QR code here, if you scan the QR code, you should be able to find the slides which I'm sharing right now. And with the QR code, you can even even it's a read only. You can still click at all the links. For example, if I want to show you the our community here, I can just simply click the link. It will take you to our landing page. That's our community. That's what we are doing. So as you can see from the screen, our mission is to empower the community to learn faster, to certify smarter, and grow stronger. So we are a non-profit organization, or we're purely just helping more community members. If I'm coming back to the slide, you can see listed here all of our community members. You can see here, you can see CubeStrong is one of our, I describe this as one of our largest node pool or node groups in Kubernetes terminology. And then we also have a few of other largest Kubernetes node pool, node groups. Guess what? Who is running the largest Kubernetes cluster in the world? I was always joking around. We are actually running the largest Kubernetes cluster in the world. So the reason is you can see we have our control plane spread across the APAC region, EMEA region, American region. We have 6 of the largest node pool, node groups. Each of the groups have the largest number of nodes. If anyone is interested to join to scan the QR code, and you can join our lucky draw. So for all the attendees, including our speakers, if you are interested, you can even join our lucky draw as well, okay? So we do have some really nice swags, thanks to our sponsors, SUSE gave us some SUSE Gecko plushie, which is pretty good, my favorite. I can show you what it is look like. Let me move this around. I can show you. So if you search SUSE Gecko plushie, you can find that's what it looks like. So we do have quite a few. We can ship to you, but only restrict to the region for those are living in UK or in the Europe. Okay. Thanks to our sponsors to support us. And we also have some other really good swags, and including Code Cloud subscriptions. Code Cloud, if you never heard of it, it's one of the best learning platform for Kubernetes, for DevOps, for cloud, for Terraform, or lots of the learning materials over there. It's a pretty handy learning platform, okay? So yeah, if you guys already scanned the QR code, that's all good. If you visited our slides, you can click the link, click the QR code instead of you scan, okay? That's the lucky draw form I put together. Yeah, we don't need your help to, follow our LinkedIn pages, and you do have the option to choose the price. What would you like? If you like the uh, SUSE Gecko, you just put the SUSE Gecko here, okay? So in the order, and then make sure you follow our LinkedIn pages, join our LinkedIn group, and subscribe to our newsletter, okay? That's it. And then come back here. Let me introduce tonight's session. Here is the agenda. So right now, I'm introducing the community here. And then shortly, we will welcome our first speaker, Eric. He is a AI specialist from Osusa. He will talk about sovereign AI proven approaches, how to leverage the AI to build something for your application in the segregated environment. Okay. And our second topic, we got three awesome speakers from our telecom cell. For those of you who are not aware, Telkomsel is one of the largest telecom company in Indonesia. Hey guys, if you guys are not speaking, not asking questions, please mute yourself, okay? So this second topic is pretty interesting. How leverage the AI-powered Kubernetes self-healing feature with the automation to do the incident case analysis. And the last but not least, we have another AI talks talking about context-driven AI agents from Shubhangi Goyal. He's a senior analyst from our Admiral Group. And the last but not least, we don't have the quiz time, or we don't have the time to have the questions to put into the quiz time. So if you already scan the QR code here, we will draw the winners from those you already fill out the form, okay? So let's continue. So I will do a little bit of intro of our community here. So our mission, I mentioned earlier, our mission is purely to empower the community to learn faster, to certify smarter, to grow stronger. And if you remember earlier, the screen I shared, just got to over 180,000 people. The guys are, most of them are technical people. They follow us, our social platforms to join us, to learn, to get certified, to grow stronger. But by the way, we're not creating a lot of the content. What I did is, if I click the link here is, let me show you. I put together all the learning certification event discount code on our webpage. And I also featured some of the videos from our community heroes, like Anna. She created a few videos like how to become a cube astronaut, how to pass your CKAD exam, for example, how to pass your CKA. And all of our meetup groups you can visit as well. So globally, just got 31,000 members. And if we don't have the meetup groups in your country, in your city, we are looking for the volunteers to help us to expand, to grow to your country, to your city. Okay. If I come back to the landing page here, if you click the discount code page, you can find all the learning certification discount we can help our community members to save bigger rather than you spend too much money. And if you're going to Cubicle events, you got a 20% off. You got some other events, you got all the discount code we put together. Okay, from the resources page, you can find all the learning stuff. KCNA learning free resources, how you can try KCSA. It's a mock exam. You don't have to pay. All of these are free. And the Killer Shell is one of the best simulator if you're doing the Kubernetes exam. Killer Coder, that's a free option. And a bunch of other information you can find from our landing page, okay? I've done enough talking here just to give you some idea. behind a part of our group, KSUG.AI community, we also create an astronaut program. Basically, think about it, it's a world's first community created certification program. So for anyone to be fully certified on AWS, you can get the title called astronaut or AWS astronaut, and then you can get the digital badge as well. And then we will feature all of the guys from our global map. If I'm going to show you here is, you can see, welcome to our astronaut club. You can see how many people from which country they are fully certified on AWS. Come back to the slide. And then after we introduced the astronaut, a few months later, we introduced another even better or even harder program. It's called CubeStrong. So that's our second community creator certification program. We do see multi-cloud is the future. That's why we put the program called Q. Let's be Cube Strong. You have to be a community hero. You're actively helping the rest. And then you are multi-cloud certified. You need at least to be fully certified on AWS plus fully certified on Kubernetes to become a Cube Strong. Okay. Alternatively, you can be a Golden Cube Strong plus two other cloud certifications to become a Cube Strong. So that's about our Cube Strong program. You can see on the screen, you can see these are 18 Cube Strong Club members. Again, if you're interested, you can click the link, go back here. You can find who are the Cube Strong members from our group. So these are the CubeStrong Club members. You can see where the guys are from, and you can filter by the country. Let's say who are the CubeStrong Club members from the US. So you can see in total they got 7. But the golden color, actually, it's even harder. You need to be golden CubeStrong plus astronaut. Okay. There are some. Is there anyone asking questions? Not questions. That's all good. So let me close this. Back to the slide. So you guys already seen our landing page, but we also created another thing. It's called a link tree. I'm going to show you the link tree. What did the link tree do? Basically, it's just we put all of our social links in the one page. That's what we call the link tree. Okay. You can find my LinkedIn here. You can find our Telegram group, our Facebook, etc. You can find all the discount code, all the learning certification event discount code from here. If you are interested to join us as a also, I forgot to mention, you can find the free AWS certification exam voucher here. How to join Google Cloud certification for free. Yeah, a bunch of tons of the information here. And one thing I want to highlight is if you haven't joined us, if you're interested to help us to volunteer, here's a link to volunteer. Here's a link on how to join us as a speaker, how to join us as a sponsor. Feel free to follow me on LinkedIn, okay? So yeah, that's a little bit about our links from a link tree. So the landing page I already showed you where you can find the latest learning certification event deals. Make sure you bookmark the page. And then before I hand it over to our first speaker, I'd like to, especially thanks to our sponsors. So first of all, Code Cloud is one of our long-term sponsor. If you never heard of this, you need to check it out. They do have lots of the great stuff. Actually, let me show you one page here. So if you go to KSUG.AI, you can find that this is Code Cloud. You can see all the logos listed here. You can learn majority of the technologies from this platform. And the best thing for our community, you can get even better discount code, better discount I will share shortly. So on their webpage, you can get 21% off. We can give you extra 20% off, which is bring down in total like 37% off. Okay. And secondly, I'd love to thank to SUSE to sponsor us the SUSE Gecko plushies. Yeah, this is the discount code from our Code Cloud. Make sure you apply this code. KSUG KK, it will bring down the cost to 144. Standard edition might be good enough for you already. Okay. So just a reminder, towards the end, we're going to draw the lucky winners from three of them. We can win the Cold Cloud Access 6 months, which is roughly about $228. And the SUSE Geeko plushies, I don't know how much is it, and even the shipping probably also pretty expensive. Just to remind, we're not shipping everywhere. SUSE only agree to ship within UK or within the Europe. So now let me hand it over to Eric to start the first topic. I'm going to stop sharing my screen. Over to you, Eric.
Great, thank you. So let me get the sharing working.
Yeah, it works.
Perfect. So I'm going to be covering basically sovereign AI and SUSE's offering in the space, and also some stories around what we're doing with customers. My experience personally has been within Europe and Middle East, so I'll share kind of what's going on there, and hopefully it aligns with what's going on in the other markets. The first thing I want to show you guys is what is SUSE AI and SUSE in general. So when I talk with people, normally they'll say, "Oh, I know SUSE. They're a Linux company." It's the only Linux company I know founded out of Europe back in the 90s. So they were founded in 1992 and basically started with Linux and then went from there. So today in SUSE, there's a lot of things that make up an entire infrastructure portfolio. And I'm just covering this to give a good baseline for how AI plays here. We have multiple Linux versions, we have multiple Kubernetes versions, we have an edge version and a central data center version. We have virtualization via KubeVirt. Again, this is all open source and upstream projects that we basically provide support for on the enterprise scale. We also have something called Rancher, which is a tool to manage multiple Kubernetes. So AKS, EKS, OpenShift are two Kubernetes flavors and a bunch of others. And on top of that, we have SUSE Security, that does basically CVE tracking, so finding all of the vulnerabilities, software firewalls, so being able to deploy your AI workloads and put a perimeter in software around them to make sure models aren't sharing data out or trying to exfil data from the inference process, and a lot of other things like policies. So if someone tries to open a SSH port or other things inside of a pod, you can either have that pod destroyed or restarted, that sort of thing. We also have SUSE observability, and this is our standard observability for managing IT infrastructure. So you can see what all the pods are doing, all of the Kubernetes resources, services, routes, ingress, everything that's going on in your workload. You can see the health of it. You can see if there's any issues, any lag, latency, that sort of thing. And on top of that, we have other things like Harbor Registry, basically RPM, and give me a second here. Okay, just checking the mute list. So the basically everything from the multiple Linux distributions we support. So we have something called Multi-Linux Manager and Multi-Linux Support. So we have a lot of customers who are running like RHEL and Ubuntu and our Linux inside, and they want to basically be able to lifecycle packages for those environments in one place. So our Multi-Linux Manager does that. And then we have some customers who are using like older RHEL and CentOS, and they want to have support for those still and not be forced to upgrade because they can't. OpenStack's a good example of why you can't upgrade old Linux distributions. So we have our multi-Linux support, which will actually go in and provide extended support even after those vendors have stopped it. But in a nutshell, SUSE is a full IT stack. Now, how do we do AI? The first thing we did is we added SUSE Observability extension for AI. What this does is it uses something called OpenTelemetry, and it takes traces and metrics from the AI workloads and reports them back into the central GUI. And again, this can all be air gapped. It can all be put inside, whatever firewall zone a customer would define to make it the level of sovereignty that they require. So none of this is going to the cloud. And in our AI extension, those traces and metrics report on all the inference. So if I go to OpenAI today and I say, why is the sky blue? It'll tell me the answer. And that entire exchange has been captured and logged by OpenAI, which is fine. That's part of their service. If I were to do that on my on-prem chatbot, which I'll show you as part of the sovereign AI approach that SUSE delivers, you'd have it captured locally. You can go back in time and look what a user asked and what they got back as an answer, which is really good if you have issues where a user says it's not working, they're getting bad results. You can go back in and look with a human eye and look what was getting answered. The other thing we do is we count tokens. So if you're using NVIDIA, for example, they have a DCGM extension in the operator, which gives you all the data on which GPUs are being used, how much power they're using, um, also the temperature and utilization. So we capture that, but we also capture what the apps are doing. And in that case, we can see that user X or user Y, over the course of a month, they use 10,000 or a million tokens. And the ability to see which GPUs are being used and the number of tokens being used, there's a lot of options customers can use for billing or for tracking usage on a per team or per user basis, or even a per app basis. So we do all of that in our observability platform as an extension. And then typically with the sovereign AI, it's on-prem. So of course, the left scenario in this one would be what would be on public cloud. But what I see within the let's say European region, is installing Kubernetes on bare metal is one approach, and I see this quite commonly in large HPC customers, so high performance computing. They'll have 3 to 4,000 nodes that are using HPC, and they'll be using Slurm and other things. But then they'll also have another environment where they're trying to start to do AI, which is a different scheduling pattern than what they have on the HPC side, and they'll go with RKA2 from us, which is our full-blown Kubernetes on top of bare metal, and of course using AMD, NVIDIA, or other GPUs. And that's usually large scale, where they're doing distributed training and distributed model serving. And this could be, of course, be sovereign, but in those cases, they're usually big server farms. The data that they're training is not considered super secret, and at least in the cases I've seen, and they're more just crunching numbers and trying to get down to the result they're looking for. The right two options in this diagram that you see are what I see in the medium to smaller accounts, and also in the accounts where they have air gapped environments. And the reason for these are that they're multi-tenant. So you think if it's a public sector, you'll have police and schools and other government entities that all want to have their own Kubernetes. So the middle option here is running SUSE virtualization on the bare metal and having Kubernetes clusters virtualized on top. And then you take the GPUs and pass them up to the worker nodes in the Kubernetes clusters where they need to do AI and have the acceleration there to do it fast. And that works pretty well because every customer gets their own API set from their own cluster. The right approach is usually when you buy a GPU like an H100, it'll have like 140 gigs of video memory inside, which is, you have CUDA cores as well, but the video RAM usually is the limiting factor when you're running a model. If you want a whole model to fit in there, 140 gig of VRAM usually correlates to maybe 180 to 200 billion parameter model would fit inside of that space. But if a user only needs to use an 8 billion parameter model, which is probably about 6 gig of VRAM, it doesn't make sense to put a 6 gig model on a 140 gig card, which you paid 60,000 euro for, or $60,000. So the right scenario is where in the hypervisor layer, you take that 140 gig and you cut it into smaller chunks. And then you give that virtual resource to the VM where that smaller model can run. So if you want to squeeze your investment out of the GPU and get more out of that investment, I see customers using this right option. The caveat here is that the virtual KVM driver that does this is from NVIDIA, which you do have to pay a license for. You don't get access to that driver like you do with the operator until you've paid and gotten through the portal to get access to it. It does support it inside of SUSE's virtualization layer, but of course that's an additional cost in the ROI of the whole platform. So again, to recap the right two, which I see a lot in the sovereign space, PCI pass-through for full GPUs or cutting them up and passing them up. The other technology that I didn't mention, which is purely on the NVIDIA stack, is the MIG or MIG. That's up at the blue layer in the Kubernetes stack. If you pass a GPU through, and if you do vGPU as well, you can still use MIG up above. There's a subset of supported GPUs that do that, so you have to, of course, check. Um, but that's another case where you can cut the resources up and share them. And then, of course, NVIDIA has other things like Run AI and such that have other similar features. Now, use cases from SUSE AI. So we have in the company a collection of open source applications curated and secured in something called App Collection. So you can imagine if I go online and I download VLLM, which is an inference engine to run models, or Olama, for example, which is another kind of engine to run models on top of, I'll get a base image built on Ubuntu, and that image might be like 10 months old with maybe 100 CVEs in it, with maybe 10 of them critical. And the project probably doesn't take care to make sure that those are always being updated. They're really focused on their application that they build within the team. So what SUSE does is we take those upstream applications and we build them on a SUSE base image where we're constantly every day rebuilding those base images to be CVE free. So basically a secure pipeline for those applications. You can think of it like being a master builder with a Lego pipeline, and you're getting Legos that are always nice and shiny and fresh, and there's nothing, chips or dents. It's the same thing, except in the security space. You're getting container images that aren't built on the one that was being used upstream, but you're getting the software from that project built on a hardened enterprise grade container package. And in that app collection, we have a bunch of AI applications. So I'm going to hop out of the view mode here. I'm going to go to apps.rancher.io. I'll put this in the chat so you guys can take a look at it at your leisure. And this is where not just AI, but all the other things from SUSE are curated. And in this, there's an AI stack. If I go here, you can see we have things like Milvus, which is a vector database used in RAG training, MLflow, Olama, OpenWebUI, PyTorch. We have a deployer for the use case I'm going to show you shortly in the stack, and VLLM. We have a bunch of other tech preview things like Kubeflow, Ray, Jupyter Hub with Jupyter Labs, and those sort of things. But those are still based on the community packages until we decide to move them over into here, basically based on customer usage. Now, the first use case here is the chatbot. So when I talk with customers about sovereign AI, the first thing they're worried about is they have a large company. They've made policies now about what their employees are allowed to do with company data on the SaaS platforms. But their problem is if they tell employees you're not allowed to go um, outside of Google's Gemini or outside of Microsoft or whatever the tool that they're using for their enterprise email and applications, they have to provide something for the internal users, and especially coders, which we'll get to shortly. Um, but in the chatbot experience, typically it's very hard to use those upstream SaaS offerings with your private data. Now there are some plugins for some of those. So a lot of the time they put a policy in place saying we have a new sovereign AI policy that requires all users not to use shadow AI. You can only use AI tools that the company provides. And if they put that rule in place, they still have to provide a way for users to get stuff done that aren't provided by the larger SaaS offerings that the company use. So the private chat comes up. And what they don't realize is that it's actually quite easy to do. A proof of concept for me, if I walk into a customer and they have our base Linux installed, proof of concept takes 40 minutes to do. It's amazingly simple. It's quite daunting for someone who's never done AI, but the combination of having a sovereign approach, meaning for most customers, this means being on-prem, potentially air-gapped, meaning there's no internet connectivity, or at least outside their corporate network, and having a way to make sure that there's no way for their internal data to be exfilled or exited from the company. And once they realize it's very simple to do, this chatbot experience comes up. And they usually do it on a single server in a POC. And then I see a lot of customers expand from there. And this use case uses OpenWebUI. Again, these are all open source upstream projects. Olama, which the two used to be one project in the past, so they work quite well together. And then Milvus. And in these sovereign AI deployments, especially when they go to production, they're taking a lot of their data that's sitting in a SaaS and synchronizing it into their on-prem. Could be SAP, could be Microsoft Docs or Google Docs, and then feeding them in through RAG training. So within RAG training, in a nutshell, they're taking that data and putting it into a data source that the models they run on top of Olama or on top of VLM can use as a data source. So, for example, all their HR docs or IT docs or um, could be hiring and recruiting with all the resumes. And then the users that are using this, they're following the company's sovereignty plan and policies, but also having something that makes their life easier or faster, or, which is basically correlating to cost savings. Um, some of the time you have more revenue generation, but most of the time it's cost savings that I've seen with the AI part. So this case works out quite well. The other one I see are when we have retail and manufacturing customers, a lot of the time they're looking at doing visual recognition, audio recognition, that sort of thing, which really falls in the machine learning bucket. And in that case, we give them the PyTorch package, and then they pull in the additional libraries they need and make their application. And that, of course, uses MLflow and Kubeflow. And then you have basically a way to train that model with new data on what they want it to be recognizing visually, or vice versa. And that model works out pretty well for them. A third use case, and this is the one that I mentioned earlier, is the coding. This is identical to the chatbot. The only difference here is that instead of a user using a web interface to ask questions or do inference, you're actually having an application like VS Code use an extension that still uses an API call to the backend AI platform to do this. And it's quite easy for coders to then use that and say, please add in comments, please review my code, look for bugs, improve it. How would you enhance it? That sort of use case works well here, and it's out of the box. Um, and what I'll do is I'll also share this. So a lot of the time when users come and they say, this is quite daunting. How do I do it? If you want to try out SUSE AI and try out some of these apps in your environment, you can of course just grab the upstream. And if you're comfortable with your Kubernetes version you have, it should work fine, with the exception of Kubeflow. It's a little bit, let's say, opinionated today, and it takes a few tweakings on the customized files. But what I'll do is I'll share this doc. It's a short blog, and we can of course repost it on the any website you want. And this basically shows how to use a single node with a single GPU to install Linux, Kubernetes, all the NVIDIA tools chain, and the chatbot on top. So this is that POC that takes 40 minutes. And once you go through this, you'll have a full running sovereign AI platform, which you can then, once you've downloaded the models, disconnect the internet connection to it and just use it on the local network, and you have a completely air gapped chatbot experience, which you can RAG train and do other things with. So with that, I think I am 20 minutes in. So we're getting close to handing over to the next group, I believe.
Well, that's pretty cool. I was surprised. SUSE, AI offering got lots of the additions. Yeah, I know SUSE only from a long time ago. You guys have the Linux, which is pretty good, and then acquired the Rancher. You guys have the Kubernetes offerings, but I never know. You guys are moving so fast. Now have the complete the whole AI suite, which is amazing. Yeah, let's see if anyone on the call has any questions to Eric. Alternatively, if you're not comfortable to ask, you can type in the chat window if you have any questions.
I'm curious if anyone's using Olama or VLLM today in the group.
Yeah, if you don't have questions, Eric might ask you guys more questions.
Yeah. Yeah, so if there's any interest, I'm more than happy to showcase. We have demos of observability of the chatbot, but I challenge the folks on the call to check out that blog. Um, and you can of course do it with your Ubuntu or your Red Hat products. They all support these open source projects that SUSE manages as well. My only caveat here is that if you guys are going to go to production, be aware a lot of my customers have stumbled with Olama. Olama is great for small deployments, but when you want to start serving more than 2 users, VLM is pretty much the only industry way of serving models after that. There's a new tool called SG Lang, Lang. I'll put it in the chat, and that's pretty much the thing that's going to come out after VLM. So it's already being used quite well in APAC region, and I'm guessing it's going to be the #1 model serving, let's say, engine in the next year.
Well, that's good to know. I never heard of SG Layer either. I personally, I learned a lot from Eric. Yeah. I don't know who else on the call. Maybe you want to add anything, you want to comment, or you have any questions? If no other questions, we will move to the second speaker. All good? All silent? No more chance. Okay. So let's welcome the second speaker. We got Doddy, we got Febryan, and also Dwiki will join us from our telecom cell. They got a very interesting topic about Gen AI powered incident analysis and the self-healing automation system. I believe that's something they are internally are using at the a telco company. So I'm going to hand it over to Doddy, Febryan, and Dwiki. Over to you guys.
Okay, thank you, Young. Good morning for the Europe time because we are on the Indonesia. Yeah, currently it is 4 p.m. 4:30 p.m. Yeah. Okay. So first of all, would like to thanks to Yongkang as a Cube Smart User Group leader for having us to this session. So to share our innovation regarding the service improvement at Telkomsel as our innovation. So we're gonna bring the topics for the Telkomsel's GenAI powered incident case analysis and self-healing automation system. Okay, next. So I also bring my team, Dwiki and Febryan, who develop our innovation for Selena, who developed Selena since early 2024 until now, together with me. And this is the agenda. So we would like to introduce our company profile. There is a cloud journey also, and our innovation, Selena. We call it Selena as an incident case analysis using GenAI. Selena self-healing automation on Kubernetes. And if you have any questions, you can raise up on this Q&A session. Next. Yeah, Telkomsel has been 30 years in Indonesia in the telco industry, and since 2018, Telkomsel start to perform digital transformation and transform from the telco company to the digital telco company by enabling the digital platform, digital services besides its connectivity services that we have. Telkomsel has more than 150 million cellular customer base and dominated with the prepaid customer around 95%. And there are 278 plus thousands total base transceiver station across Indonesia. And there are 9.8 million fixed customer base contributed from the IndiHome, and there are 19K plus petabyte total data traffic in 2024. Telkomsel always innovate to improve customer satisfaction, customer experience with the Telkomsel product, such as prepaid, postpaid, and also digital services. Okay, next. So this is our cloud journey. Since 2021, Telkomsel built the CCOE team, Cloud Center of Excellence, and that time also Telkomsel perform and or conduct for the first cloud tender to select the best hyperscaler for Telkomsel. And after cloud tender close, so we built the landing zone. We migrated several digital channel front end and backend application and cloudified the BI workload. And in 2024, we continue also to improve the enterprise codification, such as data modernization, network workload, FinOps, DevSecOps, and we try to assess the platform engineering or IDP. So in early 2024, we focused to build the automation in line with the several innovation ideas that we have with our cloud roadmap. And Selena was built in early 2024 from the pain point that we have to have a streamline the process, to have a 360-degree visibility of our system, and to have a rapid service recovery after we completed migration to the cloud. Next. So this is the Telkomsel hybrid cloud architecture that Telkomsel implemented since 2022 until now. So on the public cloud, there are digital channel front end, such as a Telkomsel. This is a self-service channel to our end user customer. There is a digital smart care, DigiPost for the outlet, sales, and many more. And there is a backend channel also like a ESB that implemented on AWS Outpost on-premise and connected to the surrounding system on-premise through the direct connect with the total capacity 120 gigabit per second. So Selena cover all of this application with the observability and self-healing capability. And for the detail, my team, Febryan and Dwiki, will explain how we develop Selena and how we manage Selena. Please, my team, thank you.
Yeah, thank you, Mas Doddy. But what exactly our problem? With so many of our application, most of them front-end channel application that have migrated to the cloud, and some surrounding application still on-premise, meaning they're hybrid. Incident can arise suddenly at any time. But the root cause of incident maybe could be from database, platform, network, etc. Next. So we answered it with Selena. Selena is a serverless GenAI-based application that help to accelerate IT incident at Telkomsel. The Selena will providing root cause analysis summaries, and also it is near real time. We can see on the previous process without Selena above, when an application success rate is degraded below 99%, the operation team will initiate a war room meeting and contact the application team, and then the other team also that involved in the application will be joining. The operation team will request to each team to check their system based on the findings and also to validate them. But the cycle will continue until operation team find the real root cause. After that, the resolution recommendation are also will come from the relevant teams, and they're also perform to solving the issue until finally the incident resolved. But see on the below side, Selena comes into the process. When application success rate is degraded, it will trigger the Selena to perform data analytic process from all metric data source that have integrated with Selena in single source database. And also the Selena will summarize the potential root cause analysis with Gen AI and also several agentic AI like a log summarizer agent, RCA agent, etc. Besides that, Selena will also provide a root cause resolution action recommendation from knowledge base. And for certain application that have implemented the new feature of Selena, self-healing feature, the resolution action will also be performed by Selena. Next. Here is Selena architecture. As that I mentioned before, we have gathered and integrate so many data source like logging data from Splunk, and then change release management data, datacom router that have connection to our direct connect service in AWS, also application metrics, infrastructure metrics, etc. All of them will be processed by Selena using serverless service, is Lambda service from AWS. And we store them into a single data source in RDS. Also, all process analytics and agentic AI that embedded with Lambda is using Amazon Nova Pro from AWS Bedrock. Also, for resolution agent, we also connect it directly with Amazon EKS Cluster to perform on specific microservices. Besides that, we also have integrated with IT operation knowledge base, including standard of procedure document. And then the last, for the user interface, currently we use the Telegram bot. Next. Here is some visual insight from the Selena. On the left side, we can see summary all the metrics, status of application, like infra, platform, network. And also we summarize it into a most critical point section on the bottom side of the message, so the user can easily get the insight. On the middle side, Selena also provide a certain grade, like a success rate trend of application, and then also provide the timeline grade. This timeline is reflect all of event that correlated with the incident. And the last on the right side, this is a self-healing feature that Selena will provide resolution action and will perform it. But beside that, Selena also using human in loop for the approval, because we think it's most important for the application team to get awareness what action will happen in their application. After approval, then finally the Selena will take action to solve the problem. Maybe next in details for the self-healing feature of Selena will be explained by Dwiki.
Okay, thank you, Febryan. Let me deep dive into the self-healing automation on Kubernetes. So in the beginning, we only focus on the incident case analysis. So we treat it as the first phase. But after that, we believe that we cannot stop just into incident case analysis. We try to add more feature, and we develop self-healing automation to gain more benefits, of course. So yeah, this is the self-healing architecture and process. Again, we are using serverless architecture, using AWS Lambda as serverless compute service to store the logic. And in this architecture, the Lambda retrieves summary data from RDS PostgreSQL, which was previously generated during the incident case analysis. And when the incident or even issues occurs, Lambda will call the AKS API or ECS API for self-healing actions. For example, restarting pods based on predefined rules. And as incident case analysis, we are still using Telegram for the notification and semi-approval requests. We are using API gateway as well, and we send the notification through the email using SES, and for the LLM we are using Bedrock. So we are using agentic AI, and we divide into two agents. The first agent is validator. So the first, we are using AWS Lambda and call the data or input error log from the RDS, and the AI will validate the issues. Then after the AI confirm this is the issues come from the specific resource, the Lambda will invoke the API Kubernetes server, so it will execute the self-healing automation. After that, the AI validator will send to the summary agent AI to generate some of summary and send the summary through the Telegram and email. So in the beginning, we are using LangChain and LangGraph, but we are currently in the process of moving to the DeFi AI platform. Okay. Selena has a significant impact on our organization, especially in Telkomsel. In the first phase, which involve incident case analysis, our process achieve faster, up to 21% faster resolution time per incident, thanks to automate data collection, insight analysis, and action recommendations. And in the second phase, we implement self-healing automation, resulting in up to 83% faster resolution times. We also publish our case study into the AWS blog. Maybe you can check out the article for more details. So this is our roadmap. We plan to integrate MCP integration. Currently, we spawn some of MCP server to integrate into our system, such as Datadog or even Kubernetes MCP server. We can use that for enrich the insight or incident case analysis. And the second one, we plan to expand the data source. We plan to add low-level log data to enrich the insight as well. And the third, we plan to add historical data and predictive capability, because as now we only collect the log data for 1 week, and maybe we can add more for the long-term historical data, where we can predict in the future for the issue, or maybe we can predict the issue in the future. And the last, we want to add multi-channel collaboration. As now in our organization, we currently use Microsoft Teams as a channel workspace. And also, we plan to create, if the incident happen, the incident case analysis will summarize the issues and the self-healing automation, but we can create the war room in the Teams for a better understanding. So, yeah, this is the summary. Telkomsel builds automation and AI to improve process efficiency, minimize service disruption, and reduce revenue losses. Because, yeah, as we know, telco industry is likely decrease in terms of revenue, right? And analytics, Gen AI, and multi-agentic AI can be combined to provide end-to-end solution, as we are currently use for our use case. And the last, our company doesn't rely on premises solutions. We are also aware that cloud is powerful. And then the cloud becomes even more powerful when we leverage automation and AI to add more value to our company. Yeah, before we close and move to Q&A session, maybe I offer to Mas Doddy.
Yeah, thank you, Dwiki and
Febryan,
for your presentation. Yeah, and this is the last slide before the Q&A. So if you have a plan to visit Indonesia, Jakarta, or Bali, because Bali is part of the Indonesia also. So please use Telkomsel as the big telco operator across Indonesia. We have postpaid, prepaid, and also the youth segmentation. And there are so many beautiful places in Indonesia, like Labuan Bajo, Borobudur, Bromo, and many things. So please come to Indonesia. Thank you.
Well, that's an awesome talk. I enjoyed the capabilities, how you guys apply the Gen AI capabilities on top of ECAS, being able to, self-healing, increase the, successful rate to reduce the time to, service the tickets, which is amazing. Let me see if anyone from our chat, or maybe anyone has any questions to the folks from our Telkomsel. Is there anyone has any questions? It's good to know. Yeah, I saw, we got 27 folks on the call right now. No questions? Silent? Once? Twice? Even no more questions? We will move to the last speaker. Thanks, Doddy, Dwiki, and also, Febryan. Thank you so much.
Thank you.
Our next speaker is Shubhangi. I don't know if I pronounce it correctly, but you can correct me. Yeah. Thank
Yeah,
you
it's
for joining us. Yeah,
Shubhangi.
yeah. Feel free to share your screen. Yeah, I realize that if I share the screen, it's there is a little bit slow to share. Yeah, her topic is about the context-driven AI agents. Yeah, over to you.
Just to double check, can everyone see my screen? Right?
Yes, I can see. All
Okay,
good.
cool. Okay, thank you. So hi everyone, good morning. I am here from London, so it's morning here. I'm going to give a talk on context-driven AI agents. AI has been the talk of the hour ever since ChatGPT came into the market. So obviously, my talk is going to be more focused on how you build those agents and then cover a use case for which we have created an agent and then the architecture of it. Before I start, I would like to give a quick introduction. I work as a senior analyst currently at Admiral Group. I have been in the space of data science and AI for the last 8.5 years now. I worked previously for an AI startup for 5 years, and I was also working for Tata Group. And these are all the forums you can see on the screen. I've spoken or I've been basically associated with in some capacity. So before I start, I would like to cover from a little bit of a context. So a lot of people, when they started using LLMs and the large language models, they thought that it's all about just using prompt engineering, and that we have a tool available for us. We ask a question and we'll get a response back. But over the course of time, things changed and evolved pretty fast. LLMs became more sophisticated. They started developing like more wider knowledge because of the wide amount of data they are trained on. They became more strategic partner rather than just becoming something as a means to get an answer. And the businesses started to look at large language models more as a means to develop models and agents that could serve a larger purpose. And hence they became more and more sophisticated in dealing with complexity of the businesses. And last but not the least, they have a systematic methodology which can gather process information that essentially comes from large sources. So prompt engineering still exists as a part of the system, but it's more about phasing the instruction. But what I'm going to talk about is context, which is around building the system that exists around the whole model. um, I'm sure everybody on this call would have heard about hallucinations, and then a lot of people think that hallucinations only happen if there is a model flaw. But a lot of time it actually happens because the context has not been grounded properly, and that leads to wrong or unreliable responses. And this actually is a bigger problem because if your application or the system that you have created is used by somebody, let's say, who is a 60-year-old person, and they don't know what the outcome you're providing is reliable, then the whole person, like purpose of that agent or the application you created gets defeated. So in the next slide, I'm going to cover some of the bits around like how what are the three main components when you are doing context engineering. So first thing first is like prompts still exist as a part of system, but they are not like guiding the whole. They're not the part of the whole thing. They're not a standalone thing. Um, Three main things that we will cover is context windows, which is basically how you shape the LLM and how they remember things. Second is system prompts, which is basically the rules, tones, and the guidelines. And the last thing is tool prompts, which is around the API calls that are required and you can use it for precision. So context window are largely important because the large language model and the amount of text and data that is a part of it, it has to remember those things one step at a time. And a larger context window basically enables an AI model to process those information faster. So if you look at the screen, like in terms of like how it is stored, this is how a context window looks like. And a larger context window basically facilitates that your AI agent can remember larger information. So think of it as like a short-term memory where everything is flowing from one step to another. But if you are like solving for like creating a agent that only serves for a session or for an episode, for example, a smaller session, then you would require a shorter term memory. But let's say you're building an AI agent that goes on for longer conversations or periods of time, then you would require a larger memory. And context window, if you see on the screen, is this is how it's stored. Like there are tokens, and you can target the tokens that you want to use when you are creating an AI agent. So if your AI agent, for example, serves public sector, and then public sector, they're focused, let's say, on council tax or serving housing responses, then your context window has to be tailored just for those use cases. It doesn't need to contain entire set of data. A lot of people actually, when they build context windows, they put a larger amount of information in the hopes that it will work better. But your context window has to be really, really tailored for the agent to provide reliable responses. And they become largely important because if you're building an application and it gives wrong responses, nobody really wants to use it. um, to cover more in detail, Context engineering is more about building a dynamic system or model that provides and guides LLM's behavior. So conceptually, it looks a lot like this. You have your RAG applications, prompt engineering, memory, state and history, and the structured outputs. But on the outer side, you have your system around the model that helps to make sure that the LLMs don't fail. And for that to happen, you need dynamic memory. And that's why memories became important, because for memories you need to have to make sure what is your use case. Do you want something which is stick to a particular session, for example 30 minutes, or you want something which goes and on for like a longer period of time? So largely there are three types of memory, but here I've covered two. First is short term memory, which is for a more sort of session based information, and the second is long term memory, which is more around your knowledge preferences, your history across different sessions, which is more used in multi-agent conversations. And so without memory, your AI is essentially, it will reset every single time. The agent that you are creating, it will reset every single time. It will not be adaptive at all, just like we want it to be for more like human-like conversations. So if you look at the screen, this is how generally context is built. So if you are creating a longer term session across different agents, so this square box is essentially your LLM without context. You provide some sort of information to it to train and ground that data on. So when we were building the agent, we used, for example, 1200, 1300 train KB articles to do that. And the next example you can see is, for example, you have some data. The data could be anything. It could also be present, for example, in terms of labeled JSON files. So essentially, you have to make sure that you provide some sort of information to the large language model to understand and train it on the kind of data you want to use. Then based on what data you have trained, you provide a step to select the context, what part of that whole data that you have provided you want to use. So for that, you can use a couple of approaches. You can use any sort of relevant tools. You can retrieve it using the long term memory, or you can use it retrieving a relevant knowledge base. For example, in my case, like if I want to retrieve only housing data, or for example only council tax data, I will only call that part of the context and make sure the context window is set only for that particular conversation. And the third problem which generally arises when building context is context overflow, which means like you have put so much data in that the agent doesn't is not able to handle, because you haven't provided enough size or memory or tokens essentially for it to handle. So on those cases, there will be a situation where you will have to compress the context, which means like you can only take a certain chunk of data. And to make that happen, you can summarize the context using relevant tokens. For example, you can only pick parts of those context that is needed for your conversation to happen, or you can trim it. You can always reduce the size of the data that you have given. So it's like if you put garbage in, it will give garbage out. Try to make sure you put very clean and grounded data, and compress it effectively so that the AI agent is able to retrieve the right uh, background every single time. And there's a fourth thing which also happens, which is around isolation of that context, which is essentially when you partition the context into multiple different states, and you hold it in, for example, in particular environment. So this is important when you are building multi-agent conversations, not a single agent, because in multi-agent you require to make sure one part of that background or the grounded data is more active than the other when it is being retrieved in terms of a conversation. So when you build a context, these are the four important steps that will generally happen. There will also be like cases when you will see that if you have taken too much data, the context will overflow. So you'll have to prioritize the data effectively. So to summarize these four process, this is like the context workflow life cycle. So first step is acquisition of that data. It could be your APIs, it could be your Wikipedia, it could be basically any article that is really, really tailored to the kind of agent you are trying to create. It could be you are working in financial services, it could be in medical or healthcare. So you have to fetch that user input and make it in the style of memory using the context engineering. Second is processing that data. Now, all the data that you have is not really important. So you have to structure and filter and prioritize which part of the data you would want to use to build it. The third is when you have done all the processing, structuring, you will have to store that data somewhere, which is essentially in the form of a memory. It could be short term, it could be long term, but will largely depend on like what is the use case. Are you trying to have a session based agent, or are you trying to build more sort of an ongoing conversation where the user authenticates themselves and the agent is supposed to remember who the user was, what their preferences was, what kind of knowledge they needed. And once you have stored that data, the fourth step is retrieval. So every sort of data that you will store, you will have to retrieve it using your memory tools, so that every single time somebody types in something, it is able to find the right context. And generally people use vector databases a lot for it, but I've heard people using like different applications. I would recommend vector databases for this part of the process. And last but not the least, you have to update it. So um, like updating the background or the grounded data is so important because your context can change over the course of time, like in month or 2 months. So your real time data has to be fed in every single time, and any outdated info has to be taken out so that your application stays relevant for the end user and it can serve the purpose for it was designed for. So in terms of architecture evolution, when we started the project, it started like this. We had an input and an output, and we took a large language model, which was more like sort of text-based conversation. But over the course of time, we found that obviously the outcomes were not reliable. So we entered a phase where like input and output, but we started giving more like context, which is like some sort of trained and grounded data. Um, and then the users felt, oh, you know what, we only have text, but I also want to use more like more proper information because I want to increase the accuracy of my output. So RAG came into picture, and RAG was built essentially on the existing trained data, which was essentially plugged in into the large language model so that the outcome stays very coherent and very, very tailored to what the user wanted. So when the text was being used, there was another use case. We thought, oh, we should also want to create like some sort of, images and videos, and for example, more sort of inputs so that we're not just stuck on using text every single time. So it was expanded to use more like wider sort of input sources, and a memory was provided. A short-term memory was provided in this case to make sure that it could retain some part of that conversation. Now bear in mind, like when you provide dynamic memory, it costs you a lot of money. So building these agents has to be taken into account on the sort of like how much ROI are you trying to make out of these agents, and then what's the business case that you're trying to solve for. So all these things have to be taken into account if you're trying to reach step 4. So from here, we realized that we wanted sort of more flexibility in terms of the kind of memory we want, and then the answers need to be faster because, for example, if I'm using an application, I would not want to wait, let's say, 5 minutes to get an answer. Maybe I want an answer in 1 minute. So vector databases were implemented to make sure that the response time is faster because they're better at semantic searches, able to find right keywords faster. And the memory was then divided into three categories, like a short term, long term, episodic. So short term memory was more catered towards like when you just want a 30-minute session. Long term was more like when a user authenticates themselves, and so they have like a larger session. So every time they're logged in, the agent remembers who this person is, what the conversation they had. And episodic was very small, like for just one time use. This was simply because using larger tokens costs again a lot of more money, and the API calls create a larger investment. So from this point, the results were largely better from where we started in step 1. And then lastly on the step 6, this is where we are going, because at the end of the day, a system can only grow when you start investing more on terms of like your retrieval layer and then what kind of safety and controls. So it's more like expansion of this process. So if in this layer we essentially added like more sort of the real time data, the user feedback essentially we are getting, so that the model keeps on learning on its own. There's an output layer which contains more sort of customized output based on the user and what they're asking. There's a service layer on the right which is more on the multi-channel delivery, so the output is not just given on just one single platform, it can come on across multiple platform. On the bottom layer there is more sort of data governance pipeline, which is around safety and control, ethics, and more around the fact that the data has to be passing through some sort of governance layers. So this is where the things are right now. Um, Here if you see in the in between, there is model 1, model 2, model 3, and model 4. This is essentially like we have divided the model into different parts, so every single time when the agent is trying to call, they retrieve the right model for the right kind of call. For example, if I'm, let's say, asking question around council tax, they actually answer the question in terms of council tax. So we divided the models and make them small models rather than keeping a one larger model, so that the cost of the application could be reduced. And this is how the agent architecture evolved from step 1 to step 6, which is way more better than what you start like when in the beginning of it. So tools and frameworks that you can use to build this model is obviously LangGraph is generally one of the most popular as well for tracing observability and like any kind of long-term state control. Llama Index or Vector DVs are great for context retrieval engines. I've used Vector DVs, so I would recommend them. Then the third is orchestration libraries, which is mostly around for multi-agent system that you're trying to create or any kind of context isolation that you're trying to build. Couple of limitations that most people run into when they build these is like over engineering the context pipelines, because they think that if we put more information in, the LLM will understand things better, but that's not how it works. So please keep only grounded and tailored data. Second thing is ignoring validation. So no validation pipeline has been created to validate the source to make sure that the outcome provided is reliable and useful. Third is context drift. So the context can change if your context window is not set properly. It drifts from one window to another. What happens generally is the response you get is kind of mixed. It's not really clean, succinct, and brief. So what happens is there is a lot of unused polluted data into it. And then lastly, the token limits becomes a big hurdle, especially if you are aiming for a long-term AI agent, long-term memory AI agent, because storage is important, how you store your tokens. And a lot of people underestimate like how like effectively they impact the outcome that you are trying to create. So these are some of the limitations most people run into when they are building these agents. So make sure when you're trying to start it from scratch, these things are thought and discussed, so that when you are, let's say, in a maturity stage of building those AI agents, you don't run into these problems, because that requires a lot of rework. And token limits and, for example, context driven actually issues that can generate not reliable like outcomes. Some more pitfalls to avoid is the first is the context window overflow. So chunking is a very good technique which really works well if you want to like prioritize what kind of context you want to use. The second is the cost. So multi-step task, they actually cost a lot more than like single step. So optimize your workflows for the kind of efficiency you want to create. And the third is any kind of governance gaps, because if you're working for specific industries like legal or medical or especially financial like I work in, so governance gaps are really, really critical. So you have to build guardrails to make sure that any kind of PII data or any specific data that you have tailored to your use case, it has to be removed. So building guardrails for governance is extremely important, because at the end of the day, responsible AI is the key. So now I'm going to cover quickly a use case, which is more around like how the AI agent was built. So the use case was like we had like a system in place where the customers were facing a longer waiting time for support, which is a very common use case. Most people would know about it. And we had some, FAQs, past tickets, but the agent struggled to surface the answers quickly, which caused a lot of like waiting times. So the agent workflow was designed around like the LLM has to reason the question that is provided. We provided like a RAG layer for context injection where like it retrieves the right policies. An action rail was built based on the knowledge base articles that we had, and response generation was done in natural language so that people can understand, relate, tailor to a customer profile that was built. And memory update was done to make sure that there's a new interaction for future personalization. So the outcome was that the resolution time, which was previously, let's say, 10 minutes, has dropped to less than a minute, because now it's tailored to a particular individual's profile. The consistency improved over the course of time because the answers were based more on knowledge based, not on the guesswork. Because previously, if we haven't provided enough context, it was working more on guesswork. This should be the answer, that should be the answer. But now, because it was very much tailored, it actually ended up focusing on the problem at hand. And the last thing, the users are happy because the customers do feel heard, and the agent, because it remembers the past interactions, it is able to retrieve information faster than before. So again, the bottom line here is like why the context matters here is because, again, without it, the agents just gave generic answers. It wasn't working effectively, and the AI actually helped the user history and the knowledge base grounding to provide specific, accurate, and trustworthy responses, which actually is what users want if you are building an enterprise scale application. So some key takeaways towards the end of this presentation to just remember is like think beyond prompting to just design systems. You have to actually think a lot more about the background of it, because that is where your intelligence, the intelligence of the large language models, gets converted into understanding. Second is agent architecture. The large language model, the tools, and the memory is extremely important with the feedback loop, because if you want the LLMs to keep training and improving themselves, then you have to keep on providing them feedback loops as well. The third is prompt engineering is not all, it's a part of the system, it's not the whole thing. You still have to work a lot more on the background of these agents to make sure they effectively work and solve the problem. And then lastly is the real world impact. Every application or every agent that you create depends on what kind of robust design that you are building. If you're building an application just for as a personal project, that's a different thing. But if you're trying to build something which is an enterprise scale application for maybe like a B2B customer or a B2C customer, then it is extremely essential to make sure that all these aspects are taken into account. So like you're basically avoiding any kind of pitfalls that are happening. And with this, my session comes to an end. You can ask me any questions if you have, and this is my QR code if you want to connect with me. Thank you.
That's awesome. Yeah, I also personally learn, quite a lot with correct me if I pronounce your name incorrectly. It's Shubhangi.
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 Okay.
Yeah,
Okay. So sorry for that. Yeah.
that's okay.
Eh, yeah. Any questions on the call? Or maybe you can ask in the chat. Let me see if anyone asking. I saw a comment from Erica. Awesome session, guys. Very interesting. Anyone has any questions?
Yeah, I'm curious to know if anyone has, built an agent and what are their, experiences as well.
Is that too hard to understand? But anyway, most of the tech people are started to shifting to learn a little bit about the AI. I know it's hard, but let's learn a little bit at one time.
Yeah,
Gradually we will get to more deep understanding of the AI things.
yeah,
I was traditionally doing the storage backup, then move to the cloud, then move to the Kubernetes. Now AI is also pretty something completely new to me. So I learned from a lot from Eric, from Doddy and his team,
yeah,
and Shubhangi as well. I think, from my side, yeah, well, I'm running the cloud native and the AI community. I think we I'm trying to leverage the platform to allow more people to join us to learn and share what they learn. So together we can learn faster, we can grow stronger. Yeah, that's our mission, trying to helping more people. I saw there is a chat. Any question? No, yeah, great session. Yeah, there is a one. Is that she asked, hey, I try to build a workflow through N8N, which is
agent based.
basically a chatbot.
That bot. Yeah, it's Anytime is like has been like in the market and like everybody's just building chatbots out of it. But I mean, what I have shown you is more like it's more like on enterprise level. So this is more like a product than like building like an agent or a chatbot for yourself, because we actually use like a lot more training articles, because you must know, right? Like everybody has used chatbots before, like they could be very clunky and they could be very unreliable. So this is the goal, is not to build something which cannot be used at more like a larger scale. So yeah, this is an example of like how the process was all about and the outcomes that we created. So, and yeah, we use a lot of like Azure AI Foundry, and then some legacy framework as well to build that. But yeah, I mean, over the course of time the results drastically improved, like when we started versus when a lot more data was grounded into it.
So is that you're answering Ramesh's question? What
um
he mentioned is great insights, tried open AI and the cloud. Is there any other tools you can leverage?
so like we use OpenAI's API for building this. I mean, you could try Claude, or like you can try, even actually if you try an older version of like ChatGPT also, or their API, the results are different if you check. Like they change and improve once you change the model that you are using as an API connection. So I would say like I would still recommend OpenAI's API to be used as like the large language model side of things. Claude is great, but I think I think if you compare the two of them, you will find that the API for OpenAI works better for like most of the use cases, like in terms of responses. Can you give some views on AI hallucinations? I mean, all the context engineering that we are doing is basically to solve the hallucinations, because everybody's talking about, oh, we are getting wrong responses, but nobody's talking about how to actually solve that, because that's where the focus should be. And as said before, like if you ground your data, if you are currently getting, let's say, 50% correct responses and 50% wrong responses, hypothetically, you can actually improve your outcomes drastically way more. Now, it might not be still 100%, but even if you are reaching, let's say, 89-90%, it's still better than being at 50%. And you have to constantly update the grounded data, because it's like the real time data keeps on changing, so you cannot keep the focus on, let's say, one set of data and be like, hey, I've used this and this is all I know about it. But over the time your data change, right? Like it could be possible you had more like information coming in, so keep on grounding that data, updating that data. Some people also use JSON labeling to label their data when they build using Google Gemini. So they use, like, they label the data 1500 sets of like trained data with like JSON labeling to make sure that the the agent that they create finds the right context when somebody tries to use it. So I think the bottom line is, make sure that you have some sort of grounded data available at hand. And people will actually see the difference when they start to do that. Before that, you will not see, you will just see hallucinations, because this is how it works, because it is too much information. You have to restrict the information that it gets and chunk your data. Chunking is a really good technique, it really works well. Chunk your data and use only that data. And if the use case is about building faster agents, then use vector dbs. Obviously it's expensive, but I mean, it depends on, like, again, like what kind of agent you are trying to build. Is it enterprise scale, or is it just something for your use, or like within a team use? So you'll have to get the buy-in from the stakeholders of the team, whoever you are in, and explain them the benefits of it. So there's like a long process before you actually start building it. So it's, again, do the due diligence in the start of the process and then start building it. That's essentially the bottom line. Yeah.
Oh, that's awesome. Yeah, we only got like a 5 minutes to go. Yes, thanks, Shubhangi, for the awesome session, and also thanks Eric and Doddy, Dwiki, and also Febryan for the all amazing talks. I'm personally surprised how the AI technology, Gen AI, actually used a lot in the real world, from a telco, from a financial industry, etc. Yeah, that's so cool. Yeah, let's give all of them a round of applause. So we can't clap. If you guys clap, maybe if I unmute, it doesn't work, but you can use the reaction. Yeah. And I'm going to share my screen again. We only got 5 minutes to go. Yes, thanks all the speakers. As usual, our community, we're trying to give away some really good swags. And if you miss for this particular one, yeah, thanks to Code Cloud, they actually give us some subscriptions. And SUSE gave us Plus, the Gecko Plus. For those of you joined us earlier, you haven't take the screenshot, or you haven't do the scan of the QR code, you can do it now. So you can be part of the winner, part of the lucky draw to win any one of the nice swags. If you haven't got our slides, and if you're interested to get one, so this is the one I already shared earlier. You can take a screenshot, take a QR. I'm going to pull up the QR code. You scan the QR code, you can get the read-only, the slides of the introduction. Okay, and then you can click basically you can click the QR code to the lucky draw screen. Okay, our next event actually is happening in a few minutes. So I'd like to thank everybody for joining us today online from Europe, from APAC. Yeah, thank you very much. Again, thanks to all of our speakers.